Everyone, my name is Anamika Rai and the roll number is 21NS0237. This is our physics assignment based on the topic MOSFET. An introduction to MOSFET. The MOSFET, also known as metal oxide semiconductor field effect transistor. It is a semiconductor device that is widely used for switching purpose and for the amplification of electronic signals in electronic devices. A MOSFET is either a core or integrated circuit which is designed and fabricated in a single chip because the device is available in very small sizes. The introduction of the MOSFET device has brought a change in the domain of the switching. And from the upper MOSFET structure, the functionality of MOSFET depends on the electrical variations happening in the channel width along with the flow of the carriers, either holes or electrons. The charge carriers enter into the channel through the source terminal and exit via the drain. The width of the channel is controlled by the voltage of an electrode, which is called the gate, and it is located in between the source and the drain. It is insulated from the channel near an extremely thin layer of metal oxide. The MOS capacity that exists in the device is the crucial section when the entire operation is across this. And this is the figure of the MOSFET with terminals. And a MOSFET can function in two ways, that is depletion mode and enhancement mode. Depletion mode. When there is no voltage across the gate terminal, the chain source is maximum conductance, whereas when the voltage across the gate terminal is either positive or negative, then the channel conductivity decreases. And this is the figure for the depletion mode. Enhancement mode. When there is no voltage across the gate terminal, then the device doesn't conduct. When there is a maximum voltage across the gate terminal, then the device shows enhanced conductivity. And this is the figure for the enhancement mode. Now let us discuss about the working principle of MOSFET. The main principle of the MOSFET device is to be able to control the voltage and current flow between the source and drain terminals. It works almost like a switch, and the functionality of the device is based on the MOS capacitor. The MOS capacitor is the main part of the MOSFET. The semiconductor surface at the below oxide layer, which is located between the source and drain terminal, can be inverted from P-type to N-type by the application of either a positive or negative gate voltage respectively. When we apply a repulsive force for the positive gate voltage, then the holes present beneath the oxide layer are pushed downward with the substrate. And let us discuss about the P-channel MOSFET. The P-channel MOSFET has a P-channel region located in between the source and the drain terminals. It is a four-terminal device having the terminal as gate, drain, source, and a body. The drain and source are heavily doped P region, and the body or substrate is of N-type. The flow of the current is in the direction of positively charged holes. When we apply the negative voltage and repulsive force at the gate terminal, then the electrons present under the oxide layer are pushed downward into the substrate. The depletion region populated by the bound positive charge, which can associated with the donor atoms. The negative gate voltage also attracts holes from the P source and drain region into the channel region. And this is the figure for the depletion mode P channel, and the other one is P channel enhancement mode. Now N channel MOSFET. The N channel MOSFET has an N channel region located in between the source and drain terminals. It is a four-terminal device having the terminals as gate, drain, source, and a body. In this type of field effect transistor, the drain and source are heavily doped N plus region, and the substrate or body of P-type. The current flow in this type of MOSFET happens because of negatively charged electrons When we apply the positive voltage and repulsive force at the gate terminal, then the holes present under the oxide layer are pushed downward into the substrate. The depletion region is populated by the bound negative charges which are associated with the acceptor atoms. And this is the figure for the enhancement mode and channel. Now, ideal switch characteristic. When a MOSFET is supposed to function as an ideal switch, it should hold the builder properties, and those are: number one, in the on condition, there has to be current limitation that it carries. Number two, in the off condition, blocking voltage levels should not hold any kind of limitations. Number three, when the device function is on state, the voltage drop value should be null. Number 4. The resistance is off state should be infinite. Number 5. When there should be no restrictions on the speed of operations. And let us discuss the advantages of the MOSFET. Number 1. It generates enhanced efficiency even when functioning at minimal voltage level. Number 2. There is no presence of gate current. This creates more input impedance, which further provides increased switching speed for the device. And the last one is, this device can function at minimal power levels and uses minimal current. Now, disadvantages. Few disadvantages are: when this device are functioned and overload voltage levels, it creates instability of the device. And the other one is, as because the device has a thin oxide layer, this may create damage to the device when stimulated by the electrostatic charge. And application of MOSFET. Amplifiers made of MOSFET are extremely employed in extensive frequency applications. Number 2. The regulations for DC motors are provided by these devices. Number 3. As because these have enhanced switching speed, it acts as perfect for the construction of chopper amplifiers. And the last one is, functions are as a passive component for various electronic elements.